Let's discuss question number 5 from test 5. This is from machine design. Okay, so what is asked? A double riveted lap joint. Okay, so lap joint, you have two plates overlapped. Okay, that's where the name overlap comes. And now you are applying double riveted, so there are two rows. Okay, I'm just drawing in each row only two, but you can understand. So it's two rows and it's continued. Okay, so now when we apply the force, we apply most of the force that comes in this way, because they withstand the shear. Most part it withstands shear, the rivets withstand shear. So it's a double riveted joint. The thickness is 15. So if you look from the side view, okay, it is something like this. Applying P here and you're applying P here, and this row is okay. So now the other things are all given. The diameter, pitch is this distance is given, pitch, and between the center lines of two rivets. Okay, and generally nothing is given whether it's cross or chain, so we just assume it to be in this way. Double riveted lap joint, 15 mm thickness. Okay, so now for shear, what is the minimum force that it withstands? So let's start with shear. So obviously when you are applying, if you take single plate, okay, and when you are applying load P, so this load P has to be balanced by here and here. Okay, so always the common practice is to specify the force per pitch. So per pitch, this is the half the rivet that is shearing, this half is shearing, so that together makes 1, and this half plus this half makes 1. So effectively two rivets that take the load, they take the shear load per pitch. Okay, so the force will be number of rivets into area of cross section into shear stress into the area of cross section of each rivet. 2 into tau into area of cross section is pi by 4 d square. So this we can just calculate 2 into, so the shear strength, we are interested in getting the maximum force. The shear strength is 640 into pi by 4 d square, which is 25 whole square. So this value comes out to be, so let's calculate this value, pi by 4 25 square into 2 into 3 20, so this comes out to be 314.2 kilonewton is the force that will cause, I mean this much force if you apply, the shear stress that is produced will be 640, and about 1 newton extra will just rupture the joint. So in shear, this much force will rupture the joint. Now coming to the crushing, so when you are applying crushing, I mean when you are just applying crushing, this part, the right half is what that takes the load, right, and this half also, right. I mean this part will be in contact, right, and per pitch length if you see, so this quarter and this quarter, so that becomes one semicircle, and the ones, and for the second row also. So this, so when I am applying P, this part of the rivet, this part of the plate will be in contact with the rivet, and there will be a compressive stress that is generated. Okay, and so the projected area is this, which is pi dt. So that load P will be taken by pi dt here and pi dt here. So number of rivets into pi d is this, is the projected dia into throughout the thickness. So this part will carry your load, this part will carry. So if I happen to draw the rivet, okay, and I'm on the plate, I'm pulling like this, so this semicircular, this part semi-cylinder will carry, so that area will be pi d is this projected into, this is thickness, and this is pi, sorry, this is d, the projected is d into t is the rectangle that will take the load. So dt is the crushing area that takes the load. So dt, okay, and into the compressive stress. So effectively 2 rivets take, because this semicircle and this semicircle, so per pitch it is 1 and 1 here, so 1 dt and 1 dt becomes 2 dt. So 2 into d, diameter is 25, thickness is 15, and the compressive strength is 640. So this value comes out to be 480 kilonewtons. So for crushing I need to apply 480 to fail it. So the strength of the joint is the minimum force that will rupture the joint in any of the mechanisms. So the minimum of 480 and 314 is 314. So this is the strength of the joint. I should be always, this is the max, or this is the maximum allowable or safe load, and minimum load which will just rupture the joint. So 314.2, answer is A. Thank you.